folder which has multiple files inside this. Now, rather than kind of spending time and going through this one by one, what we do is that we just kind of execute this command, and it will tell me that, okay, in the pcap file, in the pcap folder, there are two files, q2 and ws.py, which has this domain for us. Okay, so this is how, that's another way, and this is the way by which, like, once you have got the data from the network forensics part, where you have known the reputation and the age parameter, now to be more confident and to do more analysis, this is how you need to kind of now jump into the host system and do the searching over there. Okay, so this is one of the thing, like, guys, how you can kind of achieve that. Okay, now
Sir, it is like we are collecting IOCs with the help of this script.
Yes.
Like, okay.
Yes. So we are just kind of, we have the IOCs, and now we are trying to see, like, and so in this scenario, as I told, like, let's say you don't have the netstate output, who made the query to this website. In that case, what you can do is that, so one of the things that can also be done is that, let's say I go to over here, and let's say that ls, let's say check internet, right? So this was the one, nano check internet.py. Okay, let me, what I will do is that I will, let's say, replace this one. Okay, let's say this is a malware, for an example. This is a malware script. Okay, and what it will do is that, let's say I will get this one. In the details part, it says phishing, and then it also says me, let's say, it tells me the URL IP address of this one. So IP address is something like around 104.21.95.28. So what I do is that, let's say I paste this over here. Let's imagine, let's treat that, okay, this is the script which the malware is using to kind of connect with the website. Okay, now what I do is that I execute this part, Python 3 check internet.py in validator noise not provided. Okay, let me just do something like let me just see what's the URL over here. Okay, so let me first try with this one. Control XY, and let's say print error fetching URL, no schema. Okay, so let me just do that quickly. HTTP. That's fine. Let's hit this now. So this website is, like, it seems like it's not active right now. Let me just do HTTPS. Okay, so this is having some issues, but netstate, this website is having some issues. But let's say when we do the netstate ANP command, what it will tell us that, okay, are there any kind of process that was making that connection? Okay, so if we, for an example, over here, we do something like, let's say, HTTPS www.facebook.com, an example, and we do Python check 3, and we do netstate. So I'm hoping we will see that in the netstate output. Okay, we are not seeing that right now, but I think this is the IP address of the facebook.com, because it was not showing up earlier. And right now the PID and program name is blank over here. Okay, so most of the time you will see that, okay, what's the program name, like the PID value and the program name, it should come up like Python. Okay, but if that data is not available, what you can do is that you can just do something like this, and like Facebook, for example, and it will tell you that there is a file internet check internet.py, which is kind of trying to communicate with this website. Okay, so that's all for this one. Domain, reputation, and age, and how you can kind of investigate going further once you are very confident that, okay, this is indeed a malicious domain. Okay. Now let me see what else discussion we have, and feel free to guys to interrupt me if you have any questions. Okay. So now the other thing is the domain generation algorithm. So one of the thing is that this is something I explained you earlier, like how this what this domain generation algorithm does. So one of the thing is that what I mean to say is that, let's say utilizing the DGA, let's say there was a domain that was generated, something like this .com. So if you see any kind of this kind of domain in the DNS log, again it will kind of highlight that, okay, this might be an indeed malicious thing, because normally thing is that malware software, the normal software, actually doesn't use the DG algorithm to kind of communicate like this kind of long domains to kind of communicate with someone. So let's say if you have any, you are using any software like any Microsoft software, like maybe like Teams software. So it will try to communicate with teams.microsoft.com. It will be really rare for any software to kind of communicate with such a long URLs. Okay. So you can again utilize this kind of parameters as a check to add more confidence that is that URL a malicious one or not. Okay, just by seeing the random length, the randomness, what we have actually checked yesterday, the entropy value, and also the length of the domain. Okay, so the more lengthy domain is, the more random domain is, it adds to the confidence that it is highly potential maliciously. Okay, there will be certain false positive, but but thing is that it most of the cases it will turn out to be a malicious domain. Okay, and it is better that if that alert is not set up, what you do is that you, being a SOC professional, you can also kind of work with the client and kind of help them in kind of setting up an alert where if any of this web domain is kind of seen, which is kind of lengthy and kind of have entropy value, high entropy value, you set up an alert to the SOC team. Okay, this is a very good alert that you can kind of set up for the clients too, or even in your own organization. Okay, so the length of the domain is something which is definitely kind of which kind of adds to a suspicious thing that it might be malicious, and the false positive is kind of really rare in these cases. And the thing is that malware writers often what they do is that before kind of as I told earlier, before kind of they are trying to kind of spread their malware, what they will do is that they will generate a list of URL, let's say the hundreds of URLs which will be generated by this algorithm, okay, and what they will do is that they will pre-register themselves, then they will pre-register them. Okay, so what they will do is it will pre-register them, and when the malware will come, what it will do is that it will try to communicate with that any of that DG domain. So let's say the DG algorithm that the malware writer was using generated this kind of domain. Okay, something like this. Okay, something like this. So what they will do is that suppose that algorithm generated hundreds of this domain. What they will do is that they will quickly register those kind of domains. They will register hundreds of this domain, and then they will initiate the malware attack. Okay, and the malware will again use a similar kind of DG algorithm. So definitely there will be in that 100 at least one out of 100 will match. Okay, one out of, so let's say the DG algorithm over in the malware side generated thousands of URLs. So definitely there's a high chance that in that 1,000 at least one will be the one that is already registered by this malware writer before. Okay, and if there's at least a one that was registered, the malware will be able to kind of have a connection with the C2 server of the attacker, and that's where the attacker will able to kind of have a remote control of the computer. Okay, so this is how. Yeah, go on.
Right. I have a confusion here. So, what is the reason that malware is generating so many random domains? What is the purpose behind it?
Yeah, so the purpose, as I told, is that definitely the one thing which actually I have mentioned earlier is that to avoid detection. Okay, to avoid detection, or I will say the more better word is avoid blocking. Okay, so avoid blocking is that let's say the malware, as I told earlier, the malware, let's say the C2 domain is, let's say it is static, for example, w.fr.com, for example, and let's say the malware is only the C2 device that the malware will try to communicate is WE dot.